We are live.
Cool beans. Actually, I'm going to tilt this towards me so I can see what questions people are asking, if any. So I just thought it would be cool at the beginning of every class we do this sort of review of what you guys have worked on this last few days since we had our last class, and then just talk about anything that's on your mind. And we'll kind of review a little bit of what we've already covered and what we're going to be covering today. From time to time, I think it would be it's just cool to let other people in, and also if any of you in the live stream want to ask any questions or comment, you can feel free to do that. We'll share it with the class as well. So just to kind of follow up, because not all of you have been able to make every class, we've been covering a lot of different things. We've already gone over, obviously we did flaring, swedging, just some basics there. I really like to focus on using tools in combination with learning theory, so that way we don't get too terribly bored. We've covered a little bit about the basic refrigerant circuit. We've covered a little bit about basics of the movement of heat and temperature, a little bit we covered. And today we're going to do a couple different things. We're going to do a quick review, but then we're also going to talk a little bit about saturation, because that's a term that's often misunderstood, and a little bit more on the basic science. So those of you who have your books, we're going to be going over refrigeration, air conditioning technology in that first chapter where it talks about the movement of heat. We'll do a little bit of that. And then we'll actually do some connecting to some equipment and make some interpretations on what we're seeing in the equipment, because we already did that a little bit in the basic refrigerant circuit last week. So we're going to follow up on that. And then we're also going to do a little bit on a ductless system, more just on the practice side. Sam is here, and he's going to test out a new product that we just recently got. It's a new type of bib kit, and we're going to test that out. But in the process, we'll also kind of go over the proper cleaning of ductless system heads and blower wheels, and talk a little bit about that today. So we're gonna do some different things. But let's just go around, talk about what you've been working on this week. Anything interesting come up? We'll start with you, Jessica.
I was at a first year maintenance, new system, and found oil on the cork tape on the liquid line.
Okay.
Bubble tested, found a small leak. I was able to locate it.
Nice. And this was on the inside or the outside?
Inside.
Inside. And so underneath so you pull the cork tape back, and so it was actually the solder joint. Okay, so it was a newer unit.
Yeah.
So it was, okay, so like just a warranty, just a poor connection.
Yeah.
Any theories on why it was leaking particularly?
It was
Just a mistake?
not the best quality.
Okay. Yeah. That's a diplomatic way of saying it. And what we find often, and we talked about this a couple classes back too, and obviously we're not even at that part yet, but we kind of keep jumping ahead and then dialing it back, is especially in residential, a lot of residential technicians get away with not getting the joints hot enough, because in residential, the connections that we're making aren't nearly as stressed as in other parts of the industry. And so we kind of get away with making these connections that maybe we never got hot enough in the first place. And it's important for us to get that entire joint hot enough that the solder or alloy, right way of saying it, pulls into that joint. It's also helpful to use better quality alloys, because those flow better and are also more ductile, so they don't crack as easily. But often it's just not getting it hot enough. Whoever's doing the brazing is afraid of burning up a valve. They're afraid of doing the wrong thing, and that's good. But often it's just a matter of just not getting it hot enough. I see my first mask complaint. If you would like to complain about masks ever on my channel, please leave before I block you, because the reality is that I don't have a choice here. This is a government school, so I have rules that I have to abide by. And if you want to hassle me, just please leave. Just I'm so over it right now. Like when you run a business with 200 employees, then try criticizing. I'm just so over it. Okay, a little emotional there. We're going to move on. So good one. So found a leak. Bubble testing is so big. I see so many people who they go right to the electronic leak detector, and if you've got oil, start with bubbles. Always start with bubbles. Matthew.
I I did an install on Friday, so that was my first time doing an install. I'm normally on the service technician side. So that was really cool to see the install process of pulling an old unit out, doing a whole swatch, change out, rebuilding platforms, doing, hooking up the condenser. We had to run new 240 up the attic to almost a 40 foot.
So why did we have to run new wire?
Because there's a furnace.
Okay, so we converted a furnace to maybe I
Heat
missed
pump.
that. Okay.
Yeah, so we had to run 120 to 240. So that was pretty fun to see that whole process and be a part of that.
Yeah, we do a lot of conversions, and a lot of people who are in heavy furnace markets, they like gas because in those markets you like the greater capacity because obviously it gets a lot colder. In Florida, though, heat pumps are great, and especially in Central Florida market because it gets cold enough here that we do need heat sometimes, but they are more efficient. And then there's just the advantage of not having to worry about the safety issues with gas as well. Now, again, so a lot of people, gas has been used safely throughout the country for a really long time. But of course, the challenge in Florida is that you don't have a lot of people who know how to work on gas properly, and that's the reason why whenever we do a new system installation, when we're doing a gas furnace, we send Max out with the combustion analyzer to do a full commissioning, because it just terrifies me. And frankly, this is one of these examples where the way that I did it for the first 15 years of my career now terrifies me to the extent that I am almost a little wary of gas, because we've just seen so many issues. We've seen gas leaks left. We've seen, people leave the ports out after doing testing on the gas valves, and a lot of that stuff is pretty scary once you realize what it can do. So yeah, take gas really seriously. But yeah, those are cool jobs when we do those conversions from gas to heat pumps. Anything else particularly that you learned from like a practices standpoint, or anything you saw or got to do that was a little different?
Actually, like wire up the condenser, so I haven't had to do that. So to be able to see where all those go, and then actually help me on a job today to diagnose, to lead into the diagnosis process of a failed high pressure switch.
Okay.
So to see where wire can come in to the board, and then where it all leaves. So I got to do all that on the install. So
Interesting.
Yeah.
Well, not ideal, but good. Yeah, and that's something that we've talked about before. In terms of diagnosing boards or any sort of control, good technicians don't jump to the thing they don't understand and say, oh, the board's bad. They look at everything else that's connected to it to see if it's something else. A lot of times you see boards get condemned because of failed pressure switches or because of wiring problems, things like that. So it's good that you went through that entire process. Cool. Chad, anything crazy? You've been doing lots of crazy stuff.
Yeah.
So Chad is actually working in grocery stores now, and he's kind of gotten thrown to the wolves. But kudos to you. Lots of good reports. I got to talk to all of your teammates today in the grocery division, and they were saying you're doing great. So anyway, go ahead.
No, Monday morning, like 3:15, I got a call for Security 1. The whole rack was down for the frozen foods on high section, and all the compressors except for one were like on high pressure lockout. So they wouldn't run, and found one of the fans on the condenser rack were down.
Okay.
But it was weird because I guess when it went out, it backfed to the board, which took that, because I had power at the board, but not to the fans. It was really weird, but.
So the fan was failed in what way? Was it failed shorted? Was it failed open?
It
It was just broke.
Yeah.
It just wasn't running. Okay.
And Rolando came out there to help out, but we had to get.
Oh, wait a second. Was this the one that they had to get the refrigerated truck on? It wasn't that one, was it?
Yeah, I told the man.
Oh, okay. Yeah, we don't want to air too much of our laundry here on the live stream. Yeah, that was an interesting one. Now, one thing to note, just a good thing to know, if you've ever got issues with large condensers where a condenser fan motor or maybe even corrosion or something is causing a high head event that maybe is temporary or you're waiting to get apart, you can take a sprinkler and put it on it.
Yeah, I did. I got a hose.
You got a hose, okay. Yeah, and that will, do as good of a job, if not better in some cases, than a condenser fan motor. Now, you don't want to run that. I mean, I've seen grocery stores where they've been running sprinklers on them for months, and that's a really bad idea because you're gonna put deposits on the coils, and they're not going to transfer heat. But in terms of sort of an emergency way of getting a piece of equipment up and running, those big slab condensers, just put a bunch of water on them, run water on them. Now, again, there's certain markets that is heresy, and you absolutely can't do that. I'm sure some of our Nevada and California people are screaming right now, but in our market, again, it's a temporary way to get something up and working. Because again, in a grocery, you got 2 hours. Otherwise, you start losing frozen product, and it gets really expensive really quick. So, yeah.
2 hour time frame, huh?
Yeah, 2 hours. I mean, and it's 2 hours from the time that you get the call, not 2 hours from the time you show up. It's 2 hours from the time the rack goes down before you start losing frozen foods. Yeah, no bueno. And that's where refrigerated trucks come in, is that in some cases you got to unload. When you've got a whole rack down, you got nowhere else to put it. If you got a case down or something, then you can put it into your walk-ins or something else. Yeah.
We replaced the fan. Got it up and running.
Okay. Yeah, that's why there was a lot of discussion about that one in the old meeting today. Cool. Nick. Yes, I want to call you Nicholas. Nicholas is the other one. You're Nick. Anything interesting?
We got a 3-day job. Started Monday. An air handler up in the attic. We're redoing the whole entire house with new ducts, adding new supplies, new returns, relocating the air handler. Condenser. So been in the attic all day.
Yeah, you look it. You look like you need a nap. Yeah, and that's okay.
Well, we're trying to hustle because we're down 2 guys, so it's kind of.
Are you putting it in the garage or are you putting it in the attic?
It's in the attic.
Yeah.
In the attic.
Attic units are tough. And like we talked about, anytime you're installing a unit horizontal, pay extra attention to condensate. Pay extra attention to the installation manual. Make sure that everything is configured the way it's supposed to, because we get a lot of issues with. And again, in attics, this is something that gets missed quite often anyway, is that the dew point in attics can be extremely high. So you're going to have more unit sweating problems in attics than pretty much anywhere. And sometimes there's not really great solutions to it other than trying to keep your airflow up so that your cabinet doesn't get too cold. But those are all things to look at. But yeah, long day, sounds like.
Yeah, it's been hustling. I mean, it's pretty good. I mean, the attic space is workable, so you're not really, but the house is pretty weird shape. I mean, I don't know how to explain it, but it's just,
Yeah, when I started Kalos, it seems like every job I did was some sort of horrible application. And later on, I think the reason that was is because I didn't have any reputation and I was too cheap. And so I would just get all the crap jobs that nobody else wanted and were pricing too high. There's a lot of historic homes and stuff in the old section of Claremont, and it was all just garbage.
That's where we're at, Claremont.
Yeah, there's one house that Nathan, my brother, who now is Chad's manager, did early on that we started it at 8 in the morning and we went until 3, just trying. It's just that every time I drive by that place, it just haunts me. So
you have to admit though, this house is gonna be nice once it's done.
Yeah, it makes a big difference if you.
It's gonna be really nice.
Yeah. Cool, Mario.
Curious about a couple of things. I was wondering about my manifold. One of the pins came out, and I'm wondering, instead of buying a new clamp set, if I should just, go with the Bluetooth.
One of the pins came out. What do you mean the pins?
In the back, one of the K. Where you plug into the back of the manifold.
Okay, it just
One
broke.
stayed in when I unplugged it, so it's separated. So that one's no good.
Okay.
So I could just get a new,
What type of manifold was it?
It's a Field Piece 380.
If it's the SM380V, that's a pretty new manifold.
Less than a year old.
Yeah, if it's only a year old, I would give a field piece. This is what I always suggest, is that if you ever have anything that breaks, that's, newish, just get with the manufacturer, shoot them an email, contact them on social media, whatever, and just say, hey, here's what happened, send them a picture. contact warranty. You don't want to spend a bunch of money for no reason if it's something that shouldn't have happened. So we say this all the time in the residential meetings. It's like, you got a tool that breaks, communicate with the manufacturer. They don't mind. So I would suggest doing that first before you do anything else, because that's a good manifold. Yeah. All right, Abraham.
I had many interesting things.
Oh, many interesting things. All right.
Yesterday to today, starting yesterday, I had this call where we had a low voltage issue, right? So I started troubleshooting the equipment, and I found that they had a contactor for the condenser and another contactor for the blower, and so they put the low voltage and the wrong one. So let's say like the grain that goes to the blower was going into the condenser.
Oh, okay, right. So because you have two control wires. Yeah,
Right.
this is actually, so let's pause here, because this is a really good. So again, to the audience online, two things. This is a very mixed group. You have some people who are in the field. You have some people who are riding. Everyone is working to some degree in the field already, but some are on their own, some aren't. And so when I cover things, I cover them, soup to nuts to make sure that everybody's being brought along. And then also with the mask thing, I'm in a public school. I have to wear a mask. I have no choice. If you don't want to watch, you don't have to. Thank you. Okay, here we go again. G-wire. So when you have a split system, you've got one conductor, one cable that's going inside to your thermostat. You have one that's going outside to the condenser. The one going to the condenser doesn't need a G-wire because the condenser doesn't have a blower in it. The G-wire is specifically for your blower call. And in fact, back in the day when you had heat-only furnaces, which this is obviously a long time ago, you didn't always used to need a G-wire. It used to be that the furnace board would control G, and so G is it's a little bit of a newer thing. Like it's one of the newer conductors in the world of controls, because back in the day it was all done by that furnace board. And so again, you don't need that G going to the condenser, but when you bring those wires into the air handler and you're wiring it up the first time, a lot of times they'll get those two confused and they won't hook up the G-wire, or they won't hook up the G-wire going to the thermostat, they'll hook it up going to the condenser. And in some systems that will cause your blower not to run, right? But in some systems, the blower will still run. And why is that, Sam? Talk loud so people can hear you.
Because the Y call on certain boards will turn on the blower motor.
Because the Y call on certain boards will turn on the blower motor, but it will turn it on into super dehumidify mode. And that's a carrier term. And I don't know that all brands do this, but if you have a Y call without a G call, sometimes on some equipment, your blower will run, but it will just run slow. So that's something to always check for. If you've got a blower that seems like it's running too slow, you want to check, obviously, if it's wired up for dehumidification, you want to check to make sure you've got your call there to make sure it's not in dehumidify mode. And then you also want to check and make sure that you've got a call on G. And if you don't have a call on G, then look for exactly what you're saying. Maybe they hooked up the wrong G wire. Maybe they hooked up the one going to the condenser rather than the one going to the thermostat.
Yeah, because they have the Y and the G wire, and they just mixed it up.
Just mix, yeah, it's a good
That
one.
was one thing, and they also had this the relay with one of those relays with the boards. So that was a problem because it was clicking. Like, I was trying to call, but it wasn't working. So there was still problems in that unit. That relay,
Okay.
because I just followed the power until there was no more power on the other side. So I had that relay doing that, and the contactors where they switch to the low voltage.
Okay, so on that relay, I would want to understand what that relay does. What's the purpose of that relay? Do you know?
Yeah, for the fan.
For the blower or for the condenser
blower,
fan? For the blower, okay.
blower, yes.
And so you had 24 volts applied to the coil,
Yeah.
but the contacts weren't consistently making. Is that what you're saying?
Yeah, it's a little confusing.
Okay. All right. So we're maybe going a little too far here, but yeah, let's that's one that if we can find a wiring diagram or something for that unit, it would be good to look over that and see exactly what you were seeing. Because you will go through a circuit, especially if you're on the low voltage side. Once you get past, if you're just kind of walking through it, once you get past the coil on that relay, you will lose. Once you get on the common side of the circuit, you will stop seeing. So it kind of depends on what you mean there, but you replaced it and then it worked, or what was the final?
It's a fact, we have two other from factory, so.
And we haven't put it in yet.
No.
Okay, okay. Yeah, you may find that that's not what's wrong.
Well, yeah, even, because I didn't do it myself. I tried to find the problem before Ryan got there.
Okay, so Ryan came out.
So Ryan got there.
Okay,
He
all right,
explained
all right,
a lot
all
of
right,
things.
Okay, yeah, okay, that's fine. If Ryan came out, I feel like you
Yeah,
probably
yeah.
got it right.
No,
Okay.
he,
Okay, got it. So one thing to always look for, though, when you have any sort of, this was a commercial unit, I assume, right?
yeah, it's a two-stage package.
Two-stage packaging, okay. On commercial equipment, when you're in a commercial building, you always want to check how the transformer is tapped, like we talked about. If that transformer is tapped for 240 and you have 208, or 230 and you have 208, then that can cause you to have lower than designed voltage. And when you have lower than designed voltage, it can cause relays to chatter. Because that coil, if you drop the high voltage going into the transformer, you also drop the low voltage coming out of the transformer, right? And so if you have it wired for 240 and you're only giving it 208, that means that you're not necessarily going to have 24 coming out either. Always something to watch for in a commercial. Cool. I think that's it. Sam, anything interesting for you? You've been doing some interesting stuff. If you're going to talk, you need to either talk really loud or you need to walk closer, because otherwise the poor people on the YouTubes aren't going to hear you. No interesting stuff. Nothing.
I had a tech call me today. Heat strips were running with full mode.
Okay.
Narrowed it down to a short in the chase between Y and W, causing those to run.
Yep. That'll do that. Now, is that actually a short? Here's the question. Is that a short?
That is a short.
So that's always a thing, because when we say short, a lot of people will say, well, a short is a circuit that results in high current, blowing a fuse, tripping a breaker. But in this case, it's a short between two switch legs. So they're both switch legs that are both powering different loads. So there are things that are connected that shouldn't be connected. Is that a short? I've always called it a short, but that's actually one of those disputed things. If it's not called a short, I don't know what it's called. It's not a long. Ooh, that's a good one. But yeah, if you have two conductors that are connected to each other, touching each other, that should not be touching each other, then you have to talk to HR first, because that is against company policy. Sorry. I'm on a roll here now. It's all the people complaining about masks that have me all fired up. No, I don't know what to do. All right, good. All right, so that's it. We're gonna go. We're gonna talk about saturation and other things, but I'm gonna let you all go. All of you who are here on the live stream. I know the audio is not great, given the device we're using here. We're gonna do some more videos from the classroom, which will have better audio. But I just wanted to kind of give you a look at how we start these classes. I think these little initial sessions are good, even though they're kind of all over the place. It just gives us a chance to talk through some real things we're seeing. And yes, I'm sorry that we have to wear masks, but unfortunately that's the rules of the school, okay? I don't want to wear them either. And I'm sorry that you have to look at me with a mask on, because I know you like the look of my beautiful face. See ya.